Recording. Cool. I don't think any administrative stuff today. We can jump straight into it. First thing I wanted to cover, because I did actually get a few questions about it for people who have already started assignment 3, was header guards, since apparently that assignment uses it. And on top of that, header guards are pretty nice to know. So let's just go over that a little bit. We learned in a previous lecture about preprocessor directives. And yes, the video is being recorded. But we learned about preprocessor directives in a previous lecture, which allow us to basically determine what code gets compiled by the compiler, at least with the define keyword, right? We can determine what code gets compiled by the compiler and which code we can just throw out or ignore. Really quick, let me move my pen over. It looks like it's on the wrong monitor. There we go. And so, if we had something like this where I put define, we'll just say debug. If I put later in my code something like this, where we said if def debug, and then we put something like cout. Hello? And then just ended if. Then this will get compiled just as it normally would. The code would happen, as if we just wrote it normally. But if I didn't have this defined or I commented out or something, then the compiler is going to look at this and say, well, if def debug, which it's not, and then just not compile this code. So it's going to ignore this completely, throw it out. Which is nice. It allows us to just not include code in certain scenarios or set up debugging super easy, like in this case. And that's great. Now, on top of that, we can use it to also avoid adding code multiple times when we're using header files, because that is kind of an easy mistake to make. Consider if I was to write, let's just say, a application that does messaging of users. Then I might have something like a user.h file that has a user class in it, all that stuff, and then a corresponding user.cpp that implements all that stuff and writes all the code. And then I might have a main.cpp, say over here, that serves as all of my main code that handles all the interfacing and graphics and stuff. And then I might have some other classes that are important for me to have. For instance, I might need a message class if I'm writing a messaging app. I might do something like message.h and write a message class in there, and then do all of its implementations in a CPP file. And what you would imagine if I was to write something like this is that all three of these CPP files probably need to know something about the user class, because that seems like a pretty common class to be using. Obviously, this one needs to know about it. So here I might include user.h. And here I might, for my message class, need to have a way to include user.h, or at least message.h. So maybe we'll just say this one includes message.h. I'm just going to get rid of the include part so that this fits in the little box I drew. But maybe we need this one to need that, and maybe the message class itself needs to know about who sent the message and then who the recipient of the message is. So maybe this message file needs to know about the user class, which is defined in user.h. So it probably needs to reference that. And then we could imagine that main probably needs both of these classes, because if you're writing a message app, probably need to know about the messages that you're sending, and then maybe also the users themselves. So you might want to include both user.h as well as message.h, because both of those classes seem pretty helpful. And so if we kind of check here, I'm just going to make that point there. and then make this, we'll zoom out a little bit, make this point here. And then when I compile it, I would compile all 3 CPP files. So I do something like g++ user.cpp, message.cpp, main.cpp, and compile them all into one big program. And the user.cpp in this case would be fine, and the message.cpp in this case would be fine, but the main is actually going to have some issues, and we can kind of see it here if we look in the diagram I drew. User.h gets included. So first off, we said that a preprocessor directive just copy and paste the code. So it's going to quite literally just take this user.h code and copy and paste it in place of that. And then I'm going to copy and paste message.h into that part. But message.h also includes user.h, so it's going to copy and paste the user.h code. And so what ends up happening is that main looks something like this, where it includes all the user.h file. We'll say it looks something like that. It copy and pastes all the user.h code, and then it copy and pastes message.h, which in turn also copy and paste user.h because of the way it works, because it included it. So it effectively, when it's all done, copying and pasting all that code, it's going to get user.h from the first time I include it, it's going to get it from the second time I include it, and then all of the rest of the code that was in message.h, like the implementations. And so it ends up including user.h twice. And so we're going to get some errors there because it's going to define the code twice, or declare the code at least twice. And so you might get something like, this is a redeclaration of this class, or some sort of similar error. We want to avoid doing that, and obviously one way we could do that here is just, well, we know this one, for instance, is already going to include user.h, so we could just ignore it and kind of not include user.h in main, and that's fine. That would solve the problem for just this. But as we add more and more files, that kind of becomes hard to keep track of, for one thing. In this diagram, it's kind of easy for me to be able to check it because I can kind of follow these arrows, these dependencies, and just see if there's some way that they all end up at the same location. So for instance here, if I followed all the arrows out of main.cpp into their final way they flow, then this path leads to user.h and this path leads to user.h, and so there's a common thing there where we're led to the same path in multiple different ways. And you can imagine if I start including in a bunch of complicated ways, that it's really easy to generate this and really hard to tell when you don't want to include, right? So even though I could fix my issue here by just removing the include user.h, it's not always easy to tell. And so we need a better solution than just doing it on our own. And a good way to do that is with header guards. What I'm going to do here is I'm going to do an example of a header guard, and we'll just do it on the user.h part here. And so the way you do a header guard generally is you do a if not defined. I don't know if we actually use this yet, but if def is for checking if something is defined, if ndef is for checking if something's not defined, and you can use that to check if the header has already been added in the past. Here we'll just say user h. It's common to do these as constant, so they're usually all capital, like you would do a normal constant. And then we write all of our code for the user class, so I do class user, write all the other stuff that I want in my user.h file, and then do the end if. So this will do it if it's defined. Now I need to make sure that the thing gets defined so that this if not def can ever trigger. So the idea here is we check if it's not defined and then put an end if at the end so that all the code is kind of collected inside of it, and then we define the thing that was not previously defined. And so if we do this, and we go back and look at our dependency graph here, then it's going to include user.h twice, but when it goes to include this second one, it's going to go from top to bottom, right, as it compiles. And so it's going to go here and it's going to say, well, okay, user.h is not defined yet, so it's going to just copy and paste all the code here. It'll hit this one, which has a second header guard. It has the check for if it's not defined, and so it'll say, well, okay, it is defined because the previous include of user.h defined that thing, and then it will just not re-add this code, because that's what a preprocessor directive, at least with like a define, does, right? It just excludes the code, and then it'll include message.h normally. So this is just kind of a quick way to avoid including the same header code twice on the same path to a CPP, and it'll just kind of save you a headache of actually having to know this and follow some sort of dependency graph like I drew here and draw it with 100 files and do all that. So I'll keep that on screen for a second, but I think I see a question. Would this go in the main or the header? Just the header file itself is the easiest way, I would think. You could also do it in main and guard the include statement as well if you really wanted it to, but I think that's harder to do, so I would just not do it that way. Plus, this way it's also nice for people who are using your code because it will keep them from also including things multiple times if they just include your header and don't know anything about it, if you're writing code for like a library or something. So I'd say just put it in the header file. And so for assignment 3, I would suggest doing that for all the header files you write. I think they want you to write three header files for that assignment, and then 3 corresponding CPP files. So on all of your headers, I would suggest doing this and then just uniquely naming all the defines. For simplicity's sake, I would just say name it in a way that it looks like the file name, because that way you know you'll avoid accidentally using the same name twice. Any questions on this? I just figured it might be important, and I did get 2 or 3 questions about it over the weekend. Or week. I guess it's been a week. Plus, I think this is good to know if you're going to take the operating systems class, because they make you code an operating system, and there's like 100 C files, and yeah, you might accidentally include them twice like me, and get stuck. And this will save you a headache. Cool. Alright. Well, on that note, I guess we'll move on to something kind of new. I wanted to do an example, that way we can get a little bit more comfortable with pointers and with inheritance and just pretty much everything that we've covered so far, and then also learn a little bit of new stuff. So let's at least go over an overview of what we're planning on programming here. I already have most of the code written because I wrote this as an example for 202 in a previous semester, but I just want to kind of get an idea of what we're writing here. So what I want to write is a kind of laggy game, not a very interesting game, that's going to have a screen and then players and enemies, and you can kind of just move. I think it's a 2D game with gravity, I think, is the way I wrote it. So we're just going to represent the player with the letter P, and then any enemies with E. And then we could also add other objects if we really wanted it to. But what we're going to do is we're going to effectively have a screen here that we're going to just draw in the console. I've already written the code for it. And then this is going to be the y coordinates, and then the x coordinates. I think I've set it up in such a way that it's like your normal math coordinates, which is not the way you would normally do graphics, just as an FYI. And then we want to be able to control the player, so I'm going to do it 1 frame at a time. It's going to be really, really janky, but that's just the way we're doing it in our terminal, I suppose. And it's going to allow the player to like move up or left, and jump and stuff like that. And then the enemy, I think maybe will auto move. It does something like that, but we're just going to program a basic game. It's not going to be too impressive, but it will at least give us an idea of how you would structure a program like that. So the first thing we should consider is that we probably want a 2D array for the screen. We're going to need some sort of screen variable. I don't think I have a class for that. I think it is just a 2D array because I want to do that for the sake of an example. And I'm going to do this 2 different ways. so that we can do some practice. So we'll just do it in the typical way with like the normal brackets first, which is the way I have it set up right now. And then we will dynamically allocate it later so that we can see how to do that. On top of that, we are going to want to have a game object class, which I already wrote down here. Basically, we know that everything's going to be in the game, and if you were to write a real game, it would be very helpful to have a class that contains all the things that something that goes into the game would need. So for instance, you might want to have a ID for the player and the enemy, so this might be ID 0, ID 1, and then as I add more enemies and obstacles and items and stuff like that, then I probably want to have more things to ID them. That way I can look them up, or if I'm debugging my program, I can print out what the ID of the thing is that caused my game to crash or something like that. Pretty standard thing is to have an ID. I might want to keep a count of all the things that are currently on screen. I might want to have certain things that represent their position. So for instance, this might be at position like 0, 16 or something the player is at as an XY coordinate, and then this one might be at like 3, 16. Actually, sorry, I said we're doing normal XY coordinates, right? This would be at 0, 0, and this would be at something like 3, 0. Just to mention offhand, normally when you do computer graphics, 0 is at the top, and whatever the height is at the bottom. Which kind of makes sense with how we do arrays, right? This is normally row 0, and then this is row 1, is the way I would think about it. I don't know about you all, but I normally start at the top and go down and then go left to right. So like this is 0, 0. This one would be 1, 2. And because of that, you're going to see things are drawn like top down. I also partially mentioned that because I know of a future assignment where that's going to be the case. So just keep in mind that Y's are normally backwards, and then also the Y comes before the X, which seems a little strange at first if you're not used to it. But I've already programmed everything so that it's like normal math coordinates, so that we don't have to worry about too much. But I guess the point being, we have all these things that all of these game objects are going to have. So coordinates and IDs and stuff like that. So it would help to have a common class that we can inherit from that contains all that stuff. So we're going to have a game object class that everything's going to inherit from. And then if we want a player and an enemy in the game, then I might have the player inherit from that. And then the player will have its own functions and variables, stuff like that, and so will the enemy. And then you can see if I wanted to keep writing a more complex game where there's multiple types of enemies, then I might decide to further extend this and keep doing different types of enemies, maybe make a flying enemy and an enemy that walks back and forth and so on and so forth, and then maybe have more variations of those, etc. So this leaves a lot of room to be able to expand upon it, but we're just going to kind of leave it as is right here, I think, is all the stuff I have. So we first need to make a game object class and then inherit from all those. We're going to need to draw all this stuff, and then I think the other thing we want is it's common to consider applications like a game or a mobile app or pretty much anything that's graphically focused in terms of frames. So I might have a game where, for those of you who aren't familiar with the concept of a frame, on frame 0 of a game, it might look like this, and then this is the way animation works too, is you just kind of update things over time, right? So I might have the player press right on their controller, or in this case my keyboard, I think is the way we're going to do this, and then the player moves from where they were. So they used to be like on the left wall, and now they're just slightly closer. And then I might press jump, and they go up, and it's going to update everything every frame. So every time a frame passes, I need to update all this code for every single item that's currently loaded into the game, and they need to do all this stuff before that frame is up. Ideally, unless we get lag. So you get frame drops if that's the case. So these are all going to have, on top of having like an ID and a position, which we're going to have another class for, we probably want these to have a update function. That way, every single player and an enemy and game object has a function called update that they can then use to update on every single frame, because that seems like a common thread that we want for everything to have. So that's just kind of an overview. Let's try to get into the code here. I've already written most of it, but what I'd like to do is kind of just take a walkthrough through it so that we can get an idea of how you might format this kind of stuff in your actual code, and then we'll try to improve on it here. I think I had deleted main so that we can actually look at it. First things first, let's look at these classes. We've used the preprocessor directive to define all the controls. This is pretty common, is to give them numbers. So here, left, which is going to be L, I think, on my keyboard. R is going to be right. U is going to be up. D is going to be down. I don't remember what I did for jump. I guess we'll have to double check. But this is pretty common. There's another way to do this that we haven't gone over yet called an enum. So maybe we should talk about that first off. An enumeration, or enum that you'll see here, is a very quick way, semicolon, apparently right there, okay, to number things really quickly and have the compiler auto-generate it for you. What you'll notice if I scroll over this is that it says like exit equals 0, left equals 1, right equals 2, up equals 3. And so let's do an example of an enumeration first. But these are just ways to number things quickly. If I was writing a program that did some sort of calendar and I wanted to keep track of what day of the week it is, then days of the week would look something like this. Thursday, Friday, and Saturday. And you could represent each of these maybe with a string and say, okay, I have a string that represents the day, and it could equal something like Sunday or Monday, and write out all the words. But that makes it easier to make a spelling mistake, because you'd have to, in your code, write all of these strings for like every day of the week if you were trying to keep track of these things. But it would also be bad because comparing strings is really slow if you know anything about processors. But numbers are really quick. Like you can just AND those together and check if they're the same, right? So this is bad. Don't ever do that. Never store things as a string if you can store them as an integer. Instead, what you might do is say, well, Sunday, that's the 0th day of the week, because we start counting at 0. Monday, that's the first day. Tuesday, the second day. Third day, fourth day, fifth day, and sixth day. And now, if we do any sort of checks or anything with this, then, you know, it'll be A, super quick, but B, we can have some sort of consistency here, and the compiler will actually be able to check it, and we won't be prone to spelling errors. But it would be kind of bad to just compare the numbers normally. Like if I was writing code and I wanted to check if two things were the same day, or if let's just say I wanted to check if a day was Tuesday, like today was Tuesday, then I could maybe have something that grabs today as an integer, and then if I wanted to check if it's Tuesday, I would check it against 2. And that's just not good to read. Like, that's not clear. If I was to remove the context of all this code that I wrote, or all this like diagram that I wrote, then this code kind of becomes meaningless if somebody just took a look at it with no context of what you're talking about. So this is bad. This is bad as well. We could then go off and at the top of our file write const int Sunday equals 0, and then const int Monday equals 1. That's a little better. Gives us the advantage of an integer, and allows us to do something like this, where I could check if today is Monday, and then that's a little bit more readable than, you know, just putting a magic number there. So a little bit better. The tedious part of this is constantly writing all of these out. I'd have to write 7 of them for the days of the week, but I might have to write a bunch of them if I was doing something longer. We can use the same idea, but have the compiler auto-generate it for us with an enum, and that's what this is here. So I've defined an enumeration called control that represents the controls of our game, and just by putting the names, which I've done in all caps because they're supposed to be constants, it will just automatically start numbering them from 0 to whatever the end is. So you'll see here, again, it's a little small, but if you can see it, exit is 0, left is 1, right is 2, up is 3, down is 4, and jump is 5. Which we could also do with a preprocessor directive. In fact, it would be faster, technically, if we did a preprocessor directive, but the performance hit, the very minor performance hit, is kind of nice just for not having to type these all out. I would say the trade's worth it. This is what I usually do. It's just called enumeration. You just put enum and then the name of the enumeration so that you can look it up later. And then all the enumerations that you want, and then it'll just auto set this to 0, 1, 2, etc. So you see here for the controls, as we get later into the code, is just going to use these enumerations, which gives us the advantage of the readability that we mentioned earlier, as well as the advantage of just using integers because they're fast to check. It's mostly just a convenience thing. I don't know if any of the assignments in this class will use it, but I rather like these a lot. Here I have constants for the screen. Resolution X and resolution Y. I don't know why it's flipped. I suppose we'll find out. I have a struct here for position that just keeps the XY position of any object. So all the objects are going to have this. We kind of discussed that earlier. And then I have a forward declaration, which we haven't gone over yet. So I figured this would be a good time to talk about it. We said we wanted to keep track of a game object class that's just going to be the parent for everything in our game. And I've written that class here. We can take a look at it first. I have a function called moveInBounds that I think just keeps a object in bounds so it doesn't like leave the screen accidentally. And then we have protected. So remember, we haven't done a whole lot of examples of protected yet, but what this means is that all of these variables are not accessible outside of the class, so it's kind of like private, but by making it protected, it allows us to use it in things that derive from this or inherit from it. This means that the player and the enemy class are both going to have access to all of these protected variables. Here we have something that is going to represent a character being how it prints to the screen. So that was like the P and the E that we saw earlier. We have a position struct, which just keeps track of the XY position of the object on screen. We have an ID, which again just said was maybe for the sake of debugging and looking things up if we were to write something complicated, and then a static variable that keeps track of how many game objects have been made. Now, last thing we have here, I have a long description of from that previous semester, is a static player pointer to the player. If you have something that's unique or you have something that you need to access frequently, it's considered common practice to keep a static reference to that thing. If we consider the framework of a game and the way you might program it, the player is kind of like the focal point of your program, right? So this is just kind of like a design philosophy. If you have something that's really, really important and you think you're going to use it a bunch, in this case the player is kind of like the focus of my game. All the enemies probably need to know information about it. I might just need to get information about the player at any given moment anyways so that I can do something with them or check if they're out of bounds or you know, whatever. Then it's very helpful for me to just be able to immediately go get it and know where it is and keep all this data on it. And so you'll see it's common to keep a static reference to it. By reference, I mean pointer. I just might use the word reference on accident. And that will allow you to just quickly look it up. That way you don't have to keep track with like some sort of data structure like an array or a dictionary or whatever, and look through that dictionary every time you want to get the player and like look through it for its ID or whatever. You can just go straight to it. If you think something's important, then that's a good reason to do it. Now, I haven't declared the player class yet, technically, right? If we start at the top of our file, I went to a namespace for whatever reason. I guess I was just showing that off when I wrote this. And then we had a position struct, and then we had this, which I just kind of glossed over and didn't say anything about. And then I wrote the class game object, but we didn't actually write anything about the player. I do still want the game object class to know about the player, though. If I ever encounter a scenario where I need to write things kind of in a weird order, so consider that I want to know about the player in the game object class, but I can't write the player class till I know about the game object, because it's going to inherit from it later, right? So I can't write the player class up here, because it wouldn't make a whole lot of sense. We wouldn't know about the game object class. But I also can't finish the game object class without knowing about the player. So I can't put them in any order where they make sense perfectly. And you can kind of get around that by doing what's called a forward declaration in C++. And this here is a forward declaration. I just put class player. It's kind of like a prototype. It's used for exactly the same reason. You just write the name of the class with the word class like you normally would, and then a semicolon, and it will now be kind of like a prototype for that class where it just says, okay, this class exists, I promise to write it later. By doing this, I've told the compiler that I'm going to write a player class, so now I can reference it in the game object when I'm writing it. So I can write player, and it'll be like, okay, well, I assume that there's going to be a player class written at some point, and we will write that. And then I can implement it later if I have to. This pops up occasionally because you'll notice that things tend to reference each other as you write more programs. So just keep this in mind. This is just a forward declaration. And then I think the rest of this is just getters and then common functions and all that. A constructor and a destructor that just prints destroyed. It doesn't really do much. Generate ID, which I thought was private, but I guess is not. I don't quite know why. We don't need to worry too much about all this stuff. We can just kind of assume that it works just based off the name, which is kind of how programming big programs like this tend to work, is you just kind of import other people's code and take their word that it works, like it's a black box. So we're just going to have to hope that I wrote this correctly. I think I did. I think it worked whenever. There was one other thing I wanted to mention about this, and I'm forgetting what it is. Yes, the important function, though, is update. We said when we were drawing that diagram that it would be helpful for all of our things in our game that are game objects to have an update function. That way we can kind of share it in common. They all have to implement it and update every single frame to do whatever it is they need to do, move, jump, die, whatever. And so we said it would be helpful to have that. Now, on top of that, it would also be nice because we talked a little bit about upcasting, and we can then be absolutely 100% sure that everything inheriting from GameObject is going to have the update function available, which means that we don't have to know whether the object that we're going to be calling it on is a player or is an enemy or is something else that is in the game. We can be guaranteed that it has an update function 100% if we put it in the GameObject class. So it's very nice to put these in the inherited class if possible, rather than rewriting it, because we can kind of keep some peace of mind. Now I've put something here in front of it that we're going to discuss in a second here that says virtual. We'll skip that for now, but that is kind of what we're going to be leaning on here in a second. The rest of this we can kind of just scroll past. I don't think the game is going to work right now, so I might have to circle back to that. Anything else related to just design philosophies? I don't think so. This is for that enum stuff that I mentioned earlier. I think the rest of this is fine. We can take a look at main. Maybe we'll just write main really quick. Let's actually get into writing our program here. We said we wanted to make a game with a screen, so I've already created a 2D object here that takes the x coordinate as the first and then the y coordinate as the second, and then I think I've written all my functions to be dependent on that. And then I've created a vector of game object pointers called objects, and this is just going to store all of the objects in our game so that we can have a list of them and we can look them up later if we have to. let's actually write the game. Let's add the main loop first off. I think there's an exit command, so we should probably check that. It's the letter X. So the way this game works is we're going to input a character every single frame, and then the player is going to move in that direction. So left, right. I don't think up and down do anything, but jump will make them move up, and then exit will just bail out of the game. So with the way I've written this, let's create a character called control, and then we'll just see in. Let's not prompt anything. Let's just assume that they know how to play the game automatically. And my arrows are going the wrong way. And then we'll just say while control does not equal X. Or better yet, let's make this more readable. I have a thing called... Oh, this already does the reading. It's called get controls. It appears to read everything. Oh, it even like prompts them. Okay. I've written all of this and handles error checking and all that. And it returns the enumeration. Okay, perfect. Actually, let me remove this. Let's call this get control function that I've written. Get controls does not equal exit. And you'll see that it recognizes my enumeration called control. There's two ways you can do this in C++. For whatever reason, it allows you to not have to specify what the enumeration type is. Probably just because C++ is really lax with typing. But just so you're aware, because other languages usually require this, you can also access your enumerations by putting the enumeration name or type name. In this case, I called it control. In this other thing here, I put enum control, exit left, right. That this is good because you might have enumerations that have the same name, multiple enumerations. Like, you know, you might have day of the week has Monday, Tuesday, Wednesday, Thursday, Friday, and then you might have some special thing like day off for some reason. You know, maybe people can only take days off on Saturday and Sunday, and you might reuse the same name for those. Then you can figure out which enumeration you're talking about by putting the scope resolution in front of it and the name of the enumeration you're talking about. Now, other languages absolutely require this 100% of the time, so good to know. I'll put it there just for the sake of the thing. But just know that if I put exit or control exit, they both mean the same thing. It's just, this way I know what enumeration it came from. But anyways, so we got get controls, that. Actually, I should keep a separate integer. With enumerations, you can also actually use it as a type like you normally would. So I'll put control equals get controls. You'll see it doesn't allow you to actually set it equal because it thinks it's an integer, but it thinks this one is different as an enumeration type. If you ever want to convert one from the other, like an integer to an enumeration or other way, it's totally allowed as long as you cast it. So this is an integer, being the 0, 1, 2, 3, all that we had earlier that represented like left and right and all that. If I wanted to convert it, I can cast it there. It says control is unscoped. Prefer enum class over enum. I think it wants me to house it inside a class, but I'm not going to. Oh well. And I'm going to do that really quick here as well. I'm just going to do it that way. That's just the way I like to do it. Is just read it and then convert it to a control. Okay, cool. So that seems to handle our getting controls every frame. Controls every frame. That seems pretty important for our game. And I think the other thing we want to do is we want to first update all of the objects that are in the game, let them do whatever movement or actions they need to do, and then draw everything to the screen. And I think I have 2 functions for that already. I think this clear screen doesn't need to be added anymore. We have a print screen. Yeah, so I'm going to print the screen. Unless I made a typo. Oh, these are game objects functions. Okay, that's alright. In that case, I gotta put this in front of it. If you have a static function, I think we went over this before, but if you have a static function, then you'll need to put this in front of it, similar to how if you were to write it outside of the class. If you're to use a function outside of a class that doesn't belong to an object, you should also put that there. In this case, I don't want to tie print screen to any specific object, so I've just made it static. And that's why I'm doing that specifically. We'll print the screen, which apparently takes something. I think it takes a screen to print. So, what do we call that screen? Okay, seems to like that. We'll tell it to print the screen that we have, and then we should probably update everything. We have a vector of all the game objects that are in our game, so let's just loop through that, and then we will... I'm just going to declare a variable there. We'll just update all of them. So for I equals 0, I less than objects dot size I plus plus, and then we'll just go into that objects vector and update everything. Dot update. Oh, we need to use an arrow because it's a pointer. So notice here I have a vector of pointers to game objects, and then I'm going to update them all using this. I think I need the screen for some reason to update them. I do. I think I just have them add themselves to the screen every frame. I probably need to clear the screen, actually. I don't think that's visually... I don't do this in the best way. Oh well. That's going to be a little inefficient, but that's no big deal. Oh, and it's going to have memory leaks. I need to fix this before I upload this. I didn't realize I made a mistake on this. Oh well. It'll work. It'll work. It's just going to be bad with memory. What was the other thing? Yeah, clear screen. Clear screen. I'll fix this before I upload it, so that it's better with memory. Let's at least try to finish typing all this stuff. Okay. So we've basically written a game here. It's very simple, but you know, all we needed to know, assuming that somebody else has written this code for us, which I did like a year ago or so, then we need to clear the screen, update everything in our game, print everything to the screen, and then get the controls for the next part. I think that should be okay. Our game should work generally fine now. First things first, let's actually add some other stuff to the game. Right now we just have a game object vector, but it doesn't have any objects in it. There's nothing in our game right now. It's just like an empty list of nothing. Let's just add some things. So we'll add a player, I guess. Dot push back. So we'll push back a player. I have a way to do that. We'll just put new player. And I don't remember what the constructors take. It probably takes like an XY coordinate being where they spawn in at. Position. Yeah, it takes a position object. We see here I've written a constructor that just takes the position that you want to spawn a player at. It's called position. And then I have another one for game objects that does basically the same thing, but also has the symbol that you want to draw it as. So if we call the player thing, just as a reminder here, because this program's kind of like a refresher, if you ever want to call your base class constructor, you can do it with colon. So this is going to call the base class game object constructor. It's going to set the position it normally would, and then it's going to set the character that we draw it as to be the letter P. On top of that, after it's done with that constructor, it's going to come back here and set that static reference to the player to this. So this is a common example where you would use this, since we hadn't gotten to one of these before, other than like the ambiguity with names thing. If you are keeping a static reference to something, then you can just use this to get the object you're talking about. So this would be another example of where you would use the this keyword. It would be kind of nice. And remember, that was just from this up here. We had a static reference to the player in game object. That way we could just tell where the player is at any point, and we can assign it when we create the player. We can have it set that variable itself. So pretty easy, takes care of itself. So I need to, when I'm creating these objects, constructing them, I need to give them positions. So first things first, let's create a position. And the position probably takes an X and a Y, so I'm just going to spawn the player at 1, 1. I think that sounds fair. So make a player, and then we'll just make one enemy really quick. I'll do a dot push back, and then we'll add a enemy object. And again, it probably takes a position, and then the constructor probably works in the same way, but it just makes the character equal to E instead. And then we'll just put a enemy at 4, 5, I guess. I don't think this will compile, but we can definitely try. Just to see if it works so far. Maybe. I doubt I've written enough stuff. Oh, it's running. Okay. Cool. So we see here in our game loop it says, please input a control, left or right. So I don't know, we'll just put right. We can't even see the screen yet. Ah, it's a little wonky with the resolution. That's okay. So, I don't know, we'll keep hitting right for the player, and it doesn't seem like the player does anything, or that the enemy does anything. But we can see for like a second it's just flashing there. I don't know if the frame rate is good for you guys, but you can see that it's flashing like updating P and updating E, so it's calling their update function, but I probably haven't written code for them that tells them what they need to do every frame. So we have like a basic idea of a game here. We have a screen, we have objects that are on the screen, but they don't do anything, and so we need to write an update for each of them. So that brings us to, oh, I'm sorry, I hit the wrong button. That brings us to our new topic that we should talk about. So we've created a vector of game objects that keeps track of any kind of game object in the game. Players, enemies, items, that kind of stuff. And we know for a fact that they all share an update function, so we can keep one single vector of game objects without knowing what kind of objects are in that game object array and be able to call update, because we can be guaranteed that they all have the update function. But we actually need to write the update function for one thing, and for another thing, we don't want them to all have the same update function. So something to consider is if I wrote the update function, with the way we know so far, if I put update in the game object class, if I was writing it and wrote class game object, I don't know what that is, game object, and I wrote a void update function that apparently takes the screen, but we'll just leave it blank. Then with the way we know how to program so far, you would be expected to write this later in a CPP file, right? You would be expected to write game object update and then define all of the code that a game object needs to do, whatever that is, which is probably nothing. If something is a generic game object, I would argue there's not really anything it needs to do in particular, but maybe we can have it do something like, I don't know, print itself, I'm updating or whatever. But we probably don't want the player and the enemy to all do that same common code. So we're kind of in a conundrum here. We want them to all have this function called update, but we don't want them to all just do the same code accompanied with that. And we also don't necessarily want to write the game object update function yet, because we want to define it later. We want to define it for a player, and we want to define it for an enemy. But if we didn't put this and we wrote it later, it would give us a compiler error with what we know so far. So we're kind of at an end here. The way we can avoid doing this is with the word virtual. Actually, one last thing, just before we get to that. If I did actually write this anyways and then overrode it, so you can actually override it if you wanted to and redefine the way it works. So I could write this and then I could, make a player class player that inherits from it, player public game object, and then it'll have the update function. We can actually have it override it or overload it, I suppose. That shouldn't have that. It'll just be like this. I could rewrite it here and have another void update, and then it will do this one instead. And then I could write like player game object and write or update and then write whatever code it's supposed to do. And then if I made a player, let's just say called P, and assume this constructor worked, and then called p.update, it would go and do whatever it is I wrote for the player code. It would execute it just fine. But we actually kind of have an issue with this if we use it with the current scenario that we have. So if I wrote where they both have their own update function, I'll just call it go and P for now, just to be quick about it. And this has update, and this has its own version of update that it does. Then if I made a player called P and then set P to update, it's going to go up. I can't spell apparently. Update. It's going to go and call the player's version of that code. It's going to update like according to the way the player says it's supposed to update. But if I did something like this where I said game object G equals player, and I store a player variable in a game object thing, which we said was fine, remember. It's okay to set a object equal to something that's higher up on that class hierarchy tree. So because a player is an example of a game object, this is totally fine and legal for us to do in terms of our programming. If I go and call g.update now, it is going to call this one, not the player update. It's going to call the game object version of the update function, even though I've written a player one and the variable g is a player in reality because I set it equal to a player like constructor thingy. It is going to still call the game object one, and the reason it does that is it bases it off of what kind of variable that you're storing it in. So because g is a game object type, even though it's storing a player, it's going to call the game object code because it associates the function that it's calling with the type of the thing that you're calling it on. I could get around this by casting, but I can't always necessarily know what it is I'm going to cast to. So for instance, in our code here, we had a vector of game objects called objects, and I don't necessarily know what the type of every single object in that array is. So we know here by looking at it that the first position, like position 0, is a player because that's the first thing I put in the array, right, or the vector. And the second thing I put in there is an enemy. So I have an idea like, oh, I could say if it's position 0, cast it to a player and then call the update function. If it's position 1, call it on enemy. That's A, really tedious for writing your code, and B, it requires you to have some knowledge of the structure of your array or vector in advance and know exactly what kind of types and what order that they're in. And C++ also doesn't allow you to check the types of things easily, like during runtime. So I couldn't check whether each game object is a player or an enemy. They don't have an easy way to check for that. And you probably should avoid checking it anyways, just because that's more overhead. That's more time you spend checking things that you could avoid. So we need some sort of way to know that it wants to call the function belonging to that specific object without relying on the type that you declared it as. So even though I made a game object here called G, it is a player, so I need some sort of way to easily make it call the player update function because it is a player. And the way we do that is with the virtual keyword. I think I started to write that in our actual code here. So I actually wrote it down in our code over here. We have the update function. I've made it virtual. And what virtual allows you to do is it allows you to override the object or the function. And by that, I mean it just overshadows the version from the base class and allows you to tie it to whatever the variable actually is rather than the type of any variable. So in that case that we had earlier, this will now call, if I make this virtual, it will now call the player version of the update function rather than the game object version, because it's going to base it off of what it is, which is a player. G is a player, rather than what the variable type is, which is not what we want. So we want something like this. We want it to be dependent on the variable, like the contents of the variable, rather than the declaration of the variable. And so this will allow us to do that. That's exactly what this means. So just to get some terminology out of the way, when you write it in the base class, it's called an override. So here I've just said, let's write an override. And the way you override a function is you just write it, and the base class version has to have the word virtual in front of it. I'm going to do a void here, just called update. I don't think it has to be marked virtual again. In C++, the way that should work is that you need to have it just match the one from the base class, and it has to be marked virtual. If you don't mark it virtual afterwards, it will go back to being normal, so it allows you to kind of flip-flop virtual and then make it not virtual anymore while you're like inheriting, which I'm not really a fan of. This means if I was to make another thing that inherited from a player, like if I had a specific type of player that also needed to update, if I didn't put virtual in front of this, it wouldn't let me override it anymore, and it would go back to the default behavior that we described earlier. So I would just always throw a virtual in front of it. That's just the way I would expect it to work in my mind, but I guess you can get some weird behavior out of it if you don't. If you have some crazy application that needs that. I don't know. That's a lot of thinking about, but I just would throw virtual in front of it if you ever expect to write it again. I'm just going to put virtual in front of this, and then what we probably want to do is we first off need to make sure that the what's it called? The parameters match. So it takes the screen as an object, and then I'm just going to finish writing this here. Now the player also needs to know the controls, more than likely. I'm forgetting the way that I did this. There was some way that I had position. So we need a way to get this control from the main. I might actually have to double check how I did this originally. I'm probably just overthinking it. Where is this? In the meantime, is there any questions while I'm looking this up? I know that's, as per usual, it's a lot of material in a very small amount of time. So feel free to ask any questions if you have them. What's this? Oh, you know what? I think I understand how I did it. I'm gonna pull it up anyways, but I think I remember. Oh, fair enough. Okay, that's okay too. That's pretty similar to what I was about to do. Okay, I understand how I did this now. The way I did this in the original implementation I had was to just handle the controls. So actually, I had it like this. I declared a variable here, and then I did this at the top. I think this is actually better. Actually, it had no variable. I didn't do any variable. I called get controls, and I just did a switch statement on it. Which is, that's probably better, actually. So let's just do a switch statement based off of controls. That's probably fine. I need more parens. So let's get the controls every frame and then just handle the controls that there are. So first things first, there's a case control left. So if the user enters left, we need to do something. If the user enters right, we probably need to do something. If the user enters jump, we should probably do something. And then up and down, I don't think really matter for what we're programming, so I'm just going to leave those blank. And then we have case control exit, so if they give an exit command, then we'll just return from the whole program, I think is okay. That's probably fine to do. And then default, we'll just do nothing. Let's write this code really quick. This is why I kept a static reference. And that kind of shows why a static reference is nice, because we need to talk about the player every single frame or do something with it. So it's helpful for us to have it. What I'm going to do then is I have game object get player. So I have a static reference to the player. I have an accessor to it called get player that just gets that pointer that we were talking about earlier. And the player sets it itself, and now I can use it to call whatever. I think I have a function called move. Update. What do I have here? Add to position. Okay. Add to position. So if the player is moving left, we're going to move them left, which means that their x. So we have two arguments to this function. The first one is how far they're going to move left and right, and then the first one's how far they're going to move up and down. We'll move -1, and then nothing vertically. And then we'll just say here that for that we want to move them 1 in the x direction and 0 in the y direction. For jump, let's just say we move them 0 in the x direction and then 2 in the up direction. That way they just kind of like instantly go upwards. And that's probably good enough there. Now I think we need to do some extra stuff in the update function itself. The player actually needs to do some stuff every frame. One thing I think would be helpful for them to do is like fall, let's just say, kind of like fall to the bottom of the screen. I already have a function called apply gravity. So let's go ahead and do that. First off, we'll apply gravity to the player. And then on top of that, I think I have a function called check or move in bounds. Did I actually write that? I think I might have deleted that just for the sake of writing it. For the sake of time, let me just copy and paste that. I'm sure I wrote it earlier. But I guess while this is loading really quick, because we've overridden this player update function, we can now define what behavior we want the player to do specifically. This is taking a while to run, but let me try running it really quick. Nope. This call add to position int referenced. Oh, I also have a function called jump. I guess I could just call that. I need to rewrite the add to position function really quick. I'm not sure why that's not working, and for some reason Notepad++ is not opening either. Let me at least just pop that in here. I'm not sure why it's not recognizing the base class version right now. I'm just gonna drop this in here really quick. I suppose I could always cast it as well. There we go. Okay. Let me get this move function that I wrote. I wrote a function called move in bounds that just keeps the player from falling outside of the screen. And we'll write it down here. Move in bounds cannot be accessed, cannot access private member. Where is this telling me the issue is? Line 95? Ah, it is just a game object function. Okay, well, I guess we're gonna have to do that. How did I do this? Man, I should have just kept this file open. How did I do this in the original version? I did it exactly the same way that I have it now. I wonder why it's not working. What's the issue here? Expect an expression. I've copy and pasted something somewhere I should not have. I don't know where that is now. I'm somehow ruining our code. I'm just destroying it. Maybe it doesn't want a virtual because the previous one is virtual. Back to semicolon? Oh, whoops. There's supposed to be a brace there. Those should all be fixed. Does it run now? Or is it going to tell me the same thing about get position? Oh, no, it's fine. I think there's one thing I made a mistake on, but we'll find out. Oh, yeah, I remember what it is. That's not a big deal. The player seems to have fallen out of bounds. That's unfortunate. I don't know where they went. And I don't know if I want to debug it right now in the middle class. But I will fix this before I put it on canvas for sure. What the player should do is just fall, I guess, but something's happened. I guess this way we can at least verify that it's doing something different than enemy, because the enemy didn't just completely disappear into the ether. So I guess it still proves my point, hopefully. That the player now does something different because we've defined different behavior for them by doing a virtual function. I think we'll just talk about one last thing, and then I'm going to try to fix this before I upload it to Canvas. Any questions really quick before I move on to the last thing? And apologies that the code doesn't work correctly right now. Okay. I'll keep an eye on chat. We'll fix this if we have time. But I want to address one last thing, which we can relate to this. I don't know if I implemented it in this version, and it's really hard to check. I don't think I ever did. We'll talk about it more next class, but I want to talk about really quick, while we're talking about virtual stuff, I want to talk about something related to virtual, which is called abstract. Consider that if I was writing this program still, then I want to be able to make players, and I want to be able to make enemies, and whatever else there is. So if we look at this class hierarchy thing again, I want to be able to make players, I want to be able to have enemies, maybe want to have items that are also game objects and other stuff, but I don't want to have just game objects. If I was to go into my game and just create something called a game object, and use the game object constructor and make a game object variable, then that doesn't really seem specific enough as far as like what I'm writing. In a similar way, if we go back to like the original example we did for inheritance, if I had a class called like animal that had things inheriting from it, like a cat and a dog, then a cat and a dog are examples of animals, and they're specific enough that you can go find a cat and you can find a dog, and that's what they are. but you would never have anything in real life that you would just call an animal and not have anything more specific that you would identify by it, right? You would look at it and say, oh, that's a cat, that's a dog, that's a bird, or whatever. So you should like never make a variable of this type. And same thing with our game object. Because it's not specific enough that it would make sense to like actually implement it. And so we can avoid doing that by marking something as abstract. C++ is kind of weird about it. It requires you to specifically modify functions to be able to do this. Other languages, you can just put the word abstract and it will know what you mean, and it will think, okay, well, now you can't make anything of that. But C++ doesn't have it as like as a thing that you can just do with a keyword. You actually have to do it a specific way. So I'm not going to open a new page. Let's just do it over here. The way I might do this, let's just say I wanted them to share a function called make noise or something where the cat would meow and then the dog would bark. Void make noise, and I would override those. So hopefully, based off of what we've done so far, you would know that this should be virtual if I want the cat and the dog to be able to do different versions of this. Then I would make it virtual, and then I would, when I go to write the cat class, for instance, I would then implement it. So I would do virtual void. Sorry, it was called make noise. And then I would just, see out meow or whatever. And then that would allow me to, whenever I call make noise on a cat variable, it would meow instead of doing whatever the animal does by default. We might not want the animal to be able to be instantiated for one thing, and we also don't know what noise a generic animal makes. So it wouldn't make sense to write the function to begin with. Allowing us to mark it as virtual at least allows us to write it in later classes, but this still expects us to at least have implemented it in the base class because we're allowed to make the base class exist. Like I could still make an animal as is. The way you can get around that in C++ is by marking a function as abstract, and the way you do it is with this syntax. You have to make it a virtual function. It absolutely 100% has to be a virtual function. And then you just set it equal to 0 is the way it works. Which I think that syntax is a little weird, but that's it's fine, I guess. This is just how it works. And so this is abstract now. Or the C++ term for it is pure virtual, but I'm just going to call it abstract because I think that's more common use. And so this class is pure virtual now, or abstract. The class itself is an abstract class, and specifically this function is abstract. And what it means to be abstract is that you don't have a defined body, at least if it's a function. It means it doesn't have a defined body, therefore it doesn't have defined actions that it takes. So my function just has nothing associated with it. It has no code associated with it, and by setting it equal to 0, I'm saying that I'm not going to write it, at least not right now. And that means that I can't call the make noise function on an animal because it doesn't know what it means. I've just set it equal to nothing. That then also means that the animal class is no longer able to be created. You can't make an animal variable because the class itself has not been done being written. So it's not clear what it does because not all of its functions are defined. In order to fix that, the only way to make something non-abstract is to then implement those things that are abstract in inherited classes. So for example here, the cat now has written a make noise function, which means that a cat is no longer abstract because it has finished writing all of the code that the animal did not finish writing. And then we have another question in chat. So to make the whole class abstract, would we need to make all of its functions? Oh, good question. All of its functions pure virtual. No. So you actually only need one or more. It can be any number, but you just need at least one. In this case, I could have a function called, I don't know, we'll be dark here and just say void die. And we'll say that all animals die the same way, and that's fine. And I could share that code in between all animals, and that would maybe make sense in this case. Even though the make noise doesn't need to be shared, like they all need to have it, but they don't need to all do the same thing when they make noise. Um, this would still be abstract, and the reason being because it doesn't know what the make noise function does. The code isn't written for it, so it's not allowed to make one. You're only allowed to instantiate an object that has all of its code defined. And in that way, that's why I'm allowed to make a cat now, but not a animal. I didn't do that for some reason in the game object implementation. I don't know why. But I could have made update abstract, and that would have made it so that I can't instantiate something as just a game object, but I could make a player and an enemy, and they're examples of game objects, so I can still store them in like a game object variable, but I can't, just have a variable that is a game object, if that makes sense. We'll kind of expand upon this in a future lecture. I guess it's just kind of an introduction. I'll probably think of an example. But I guess it is a little over time. If anybody has questions, I'll stick around. Assignment 3 is due next week, and I'm going to fix all this code and upload it to Canvas, hopefully either tonight or tomorrow. I guess it depends. But yeah, if anybody has any questions, feel free to stick around, and I will see you all next week.